Hello, everybody. Welcome, Matteo. So Matteo is the CEO and founder of Orion Finance. And Orion Finance is a portfolio management protocol. So it's designed to optimize on-chain capital efficiency while obviously preserving privacy for managers and auditability for users. So it integrates advanced cryptography like FHE, what we do at Zama and the FHE VM. And the goal is to power private vault strategies, encrypted performance tracking, and protecting manager alpha while maintaining something auditable and verifiable. So that's enough from my side. Welcome, Matteo, and I'll let you present and demo Orion Finance.
Cheers. Thank you very much, Jason. Nice to see you, everyone. Yeah, it's a pleasure to be here. I would like to present more starting from the business scale, let's say. So the opportunity we saw and why we started working using Zama. We saw a big growth in asset management being performed on chain. This was particularly happening last summer when what's called now risk curator wasn't even a category. We were around here looking around the growth of the vault curation business. That overall, with a few exceptions, let's say more historical, started getting a lot of traction in the world of lending. We really saw this appearing, and we saw an interesting opportunity and I would say contradiction in the market, in the sense that today we have a few billion being managed in so-called vaults. Probably many of you are familiar with vaults. Vaults enable us to tokenize funds and basically to exchange an underlying token with a shared token that's built to systematically and algorithmically via smart contract technology follow the P&L of a strategy, profit and loss. Now, in the business model of asset management, of course, there is a fee structure that's associated with the manager itself. That is a management and performance fee usually. So I would say coming out of this reflection, looking at the opportunities offered by blockchain technology, we identified what we see as a contradiction in the sense that asset managers today wanting to benefit from inhabiting on-chain asset management, so making use of 24/7 settlement, verifiability coming with the transparency, composability, all these beneficial properties of not only tokenizing assets on-chain, but tokenizing basket products, let's call them, so portfolios on-chain, are today obliged to take in full transparency when it comes to wanting to benefit from the composability and verifiability of blockchain. Of course, there are a few exceptions coming from standalone and solutions built exactly for this, but the value added in Zama is specifically that we can tap into the liquidity of, in this example, Ethereum mainnet without breaking down the liquidity and losing composability opportunities. So we can really benefit from the value of a mainnet, an L1 or even L2 EVM chain without giving up on the depth of the liquidity. So I would say this is where everything started. Another important feature that we value a lot in the FHEVM ecosystem is the selective privacy feature we can have. Today, of course, it's difficult to build privacy-preserving portfolio management solutions that are built on baskets of privacy-preserving tokens. Of course, there is a big use case in confidential token per se, confidential swaps. And if you look into some documentation, there is a lot. But for us, it was really about the confidentiality of the alpha, so of the strategy generating the profit and loss of the shared token associated with the vault, rather than protecting the privacy of the LP tokens being exchanged as an underlying for the vault. And this is very useful in the way of building smart contracts using FHEVM, because one, as a builder, can discretionarily select features that require privacy and features that require full transparency. And I would say, in general, it's super powerful to inhabit an infrastructure in which verifiability does not necessarily imply transparency. So what we like about Ethereum, we never say, like the famous sentence, don't trust, verify. We never say, don't trust, look. The transparency is a way for us to verify. And we really don't care about the transparency per se. What we care about is the verification. And verifiability with FHEVM is very powerful. And yeah, we can dig into how we enable this. Maybe before starting with the code, I wanted to go through our infrastructural design so that you understand how privacy is achieved. In the Orion protocol, basically, we have a pseudo smart contracts, EVM, in which we enable asset managers to deploy funds. These funds belong to a whitelisted investment universe assets. So these funds can be confidential, but can also be non-confidential. Think about the case of fully passive products in which the allocation of a basket of assets is solely determined by on-chain states. There is no need for an off-chain entity with alpha or IP that's driving the allocation of capital. Well, in this case, also privacy is not that needed. At the same time, with more aggressive strategies in which both the information and the IP of the manager is highly valuable, confidentiality plays a big role. So in our infrastructure, today we are able to deploy both transparent and encrypted vaults. Today, of course, we will focus on encrypted. And the privacy is, how is it achieved? Our protocol is the first intent-based vault curation infrastructure. This means that curators are not submitting rebalancing orders, directly interacting with the markets. And this could be morpho markets, yearn vaults, morpho meta vaults, Pendle principal token and the yield token. At the end of the day, here it's a matter of defining the right adapters for liquidity management. This interaction between there is no direct interaction with the orders of the vault curator, vault manager, portfolio manager. Now curator has become the word, but portfolio manager is the word in traditional finance. There is no interaction between portfolio managers and the actual investment universe. There is just a submission of an intent, so a target portfolio. In our case, a target portfolio is, and I guess I can show you directly from the code base. Let me see, what is the protocol? Yeah, in particular in the encrypted vault case. Sorry, I'm in the factory. It's defined as a list of encrypted intents. The encrypted intent for us, it's a tuple of token, so the asset I want to buy, and the weights. We decided to define an interpretation here, which is weight in the sense of percentage of TVL, since this is the natural way for asset managers and quants to define a portfolio. They have a certain AUM, assets under management. In the word of DeFi, this is TVL, total value locked. And they're interested in defining an allocation that's defined in percentage. This is useful also to perform risk management, so covariance estimation, tail risk management, so to use a normalized unit. And at the end of the day, the vault is defined as a list of these objects. So we can define an intent, which is submitted by a portfolio manager, as a list of tuples, in which the weight in this encrypted case is an external EOINT, encrypted integer coming from the FHE library. Then, as I said, there is a degree of separation between the liquidity and the manager because, of course, there is some kind of batching happening, enabling obfuscation and confidentiality, in which asynchronously we have an engine that's in a centralized manner is able to pull multiple intents from multiple Orion vaults, batch them in an encrypted sense, and then decrypt the outcome. This enables us to have a system in which not even the deployer of the protocol itself are able to reverse engineer the target portfolio of a manager. And of course, given that this is valuable specifically for cases in which the IP is off-chain, nothing about the strategy of the vault manager is visible, but of course, the LP interactions, and more specifically, the P&L line, what's called the equity line of the fund. So the historical time series of the prices of the share token associated with the fund. And this is usually the setup you have in a hedge fund-like infrastructure. With this, however, because the token associated with the confidential fund is an ERC token, you gain all the value of being part of an EVM chain. So you have composability, real-time settlement, full auditability. You can also play with the degree of permissioning you want to achieve in a vault. In fact, we set, and again, here I can show you in the parent vault contract, a vault whitelisted asset. This means that a manager may be interested in enabling LPs to verify that the strategy is investing only in a set of whitelisted investment universe assets without actually revealing the strategy. And so there is an interesting balance between how much the manager wants to reveal about the strategy and how much needs to be protected to justify and maintain the hedge, basically. Okay. So, hoping the architecture is clear.
Maybe, Matteo, we already have a few questions from...
okay, I guess we can stop here for, before jumping into the code.
Yeah, I think it's some general questions you can easily answer. So first one is, so can I understand that Orion Finance is kind of a DeFi app with FHE feature? I think the answer is yes.
Yes.
So this was from Chen. Then another one is from Neo. How is Orion Finance using Zama's FHE to protect portfolio data? What's the real difference for user versus regular vaults? So right. I think the question is from the user's perspective, what concretely, without talking about the tech, what is changing?
Right. I would say the good thing about users in the sense of LPs in the vaults don't have a big UX disruption. We have an app that we are actively working on, and this is what we have today. The UX of the LP interacting with the vault is the same as any other DApp, main DApp. There is the ability to deposit. There is an underlying token associated with the Orion vaults. And these are redeemable using the shared token of the vault. So nothing changes. ERC20 for ERC4626. Everything is transparent. The amounts are visible on chain. What's different is for the curator. And that's a bit nuanced in the sense that from the perspective of these users, nothing is changing. Like the user experience here and here is exactly the same. What is different here, I would say we worked hard to make it seamless for portfolio managers as well. And we can show you now in the demo how it is the case. To have a same UX, both for interacting with a confidential fund and a fund. So that, and I would say also, yeah, the SDK from Zama and everything that's part of the Zama coprocessor did a lot of heavy lifting. We tried to do an extra mile in providing the same UX for managers as well. But we can look then at the contracts. So the implications are at the contract level. And that's where the tricky part happens when it comes to protecting the hedge of an asset manager on chain.
So I'd like our audience to understand very well this point. Can you explain a little bit more who are the big portfolio manager you are mentioning? Whose life will be different once this product is in production?
Yeah, definitely. So a big family is what I call risk curators today. These are managers that are inhabiting already blockchain protocols. And you have a new category that came up a few months back on DeFi Llama, and you can just scroll over them. As I said, the market today is mature when it comes to managing basket products of exposure to lending market. But there is a big market of tokenized products in which there is an active off-chain management happening already outside the lending. Something else maybe to be stressed, and I guess this goes hand in hand with our conversation with ABN AMRO, a Dutch bank that's looking into digital assets. Something to stress is that today, looking at DeFi Llama, we can see the TVL associated with players that are already in the field of on-chain asset management. It is yet to be determined the size of the market for asset managers that are willing to go on-chain and experiment with this technology, but are blocked, among other things, because of the lack of privacy. So, we have digital asset managers such as Vanek, Fidelity Digital, Keyrock to some extent, that are more, and ABN AMRO, of course, is another one, that are more and more digging into digital asset technology. And we hear from many of them that privacy is a blocker. So life would change for these players to the extent that they would finally be able to participate in the on-chain asset management economy.
All right. So right now they are not on DeFi. They cannot join because it's too transparent, and they don't want to reveal their strategy to the entire world. We have a good transition with the last questions we have for this first part from Hoa Hung. So in the current blockchain and security market, there are many other solutions being developed. How do you assess Zama's competitive position? And what are its biggest strengths and the area of improvement? So this is a really good question. I'll let you, Matteo, answer. But I can just, for the context, give other privacy solutions, which are ZK-based, TE-based, MPC-based for some of them. And one big competitor that we often forget is just centralized TradFi, which is our biggest competitor in the space. So what's the difference with Zama from your point of view, Matteo?
Yeah, thank you. Yeah, thanks. Also, yeah, I appreciate the distinction you made. Like, there is a bit of a tribalism when it comes to solutions for privacy preserving infrastructure. I think you did a great job you are doing a great job with the Open Zeppelin initiative to abstract away that differences and stress more the added value we can bring to the big market of asset managers that are already still part of TradFi. So one big distinction I see, I mean, when it comes to distinction between doing asset management on-chain versus off-chain, as I said, composability, 24/7 settlement, no minimum ticket size, and therefore big democratization. These are all valuable things that we should keep in mind. Now, keeping these in mind, starting to perform asset management on-chain brings some problems that we see solutions being implemented to do this. Aztec as an L2, other blockchains which are not compatible with Ethereum mainnet, for example. I'm thinking about Rails or Canton Network more recently. All of these give up on the deep integration with an L1 like Ethereum. So they give up on security, they give up on liquidity, and I would say that all these reasons are a big driver for us to go with Zama, because we can take everything that's already existing, bulletproof mainnet Ethereum. That's something we trust in. That's where the market is mature, and there is the case for building portfolio products. And just add it's as easy as adding an import in your vault contract. I think 2 in this case, yeah, 2. And you're good to go, and you don't need to change anything about the composability you have with third-party protocols. And I would say that's the main driver. Am I forgetting something about the question?
No. I think you did a great answer, and you highlighted 2 of the core features of Zama protocol, which are, first, as you mentioned, you can build and you can tap into existing liquidity. So today, if we zoom out, most of the liquidity is on Ethereum for DeFi. Most of the stablecoin are there. So instead of launching a new layer, and we are seeing lots of new layer 1s recently, a new layer 2s, a new ecosystem, you can stay where your money already is. This is big compared to most of the competitor. And the second one, as you mentioned also, is the simplicity of the DevX. You just have to you use Solidity. It's a simple new data type, and it's quite easy to integrate for them. So thank you, Hoa, for these questions. So if you'd like to go on with the demo, Matteo, go on. We still have many more questions, but I'll ask a little bit later.
Yeah, okay, thank you. Yeah, let's try to dig a bit deeper into the contracts. So we can close these. By the way, our protocol is open source, so feel free to take a look. We are happy to work in this way. So I think we can go straight into the contracts. Let me think about what's the best way to move forward, because I would like not to waste time on the transparent equivalent. As I said, there are 2 places. Maybe let's go super fast on where FHVM is integrated in our smart contract suite. As I said, the encrypted vault. So here in this contract, we are here. We are in this contract here. And these are the 2 imports we do when it comes to Zama. The Sepolia config is something we need to inherit from when we define the contract, so that we can, our contract knows where the coprocessor is and all the various gateways that live off-chain with respect to Ethereum mainnet, of course. And here we import a few types. So we have an encrypted integer, encrypted Boolean, and the FHE main object. In our intent-based protocol, we have two states. One is the intent submitted by the portfolio manager, which, as I said, is a list of addresses and percentage of TVL in an encrypted form, and portfolios, which are representing shares. I think we can go fast on this, but the function I would like to show you is basically this submit intent. I think it's the most interesting one. And it's what's enabling us to take the perspective of the asset manager. Because as I said, there is nothing innovative, and I guess in a good sense, about the interaction of the LP with these products. It's like any other DApp. You don't see any difference. I would like to show you how, to the extent to which a curator also doesn't see a big difference. So the submit intent is associated with an encrypted list of objects. The additional, and this is something you also see in the Zama documentation, there is a proof that's enabling us not to blindly trust a black box living off-chain, but to receive some guarantees about the computation being performed off-chain when it comes to encryption in this case. Yeah, I don't think there is a lot to discuss here, at least not worth doing it now. I would like to go straight into the callback function. So, as you know, Zama is able to decrypt asynchronously the states submitted to the contract. So in this submit intent function, for example, we have this is intent valid flag, which we set to false by default, and we let the Zama coprocessor give us back the decrypted state of this variable. So what is a valid intent for us? It's an intent for which each address belonging to the submitted intent list is whitelisted in the vault. And it's an intent in which the entries of the quantitative values sum up to 1 and are all positive definite. So the beauty of FHE is that we can perform operations on encrypted numbers, and that's why it's homomorphic, returning encrypted results and then decrypted results without needing to know anything about the intermediate states. So in this case, we initialize the total weight as an encrypted 0. So this is an encrypted number that we initialize to 0, but in the world of encrypted numbers. We then go forward, summing up intermediate entries of the weights vector. So these weights, we need to perform a transformation from the external encrypted type into the actual EUINT 128. That's a nuanced step. The interesting one is this addition. This is an addition performed in the world of encrypted numbers. So we take encrypted 0, we add it to encrypted something, which we don't know what it is. We can do this for every weight entry of the portfolio, and then end up with a total weight state that is summing up to something. Once we have this, we can validate the intent by asserting some equality condition, again in the world of encrypted numbers, the encrypted states. It's not necessarily a number. In fact, this is a Boolean. So we have an encrypted true or false that we don't know in advance what it is. So this is basically we've shown a map that brings us from a vector of encrypted integers to an encrypted Boolean. And then we can decrypt the state of this Boolean without any knowledge about the individual entries of the encrypted weights, which is where the IP lives. So this is needed. This is not really the core of how we enable confidentiality, but it's the first point in the protocol in which we intercept with the value of FHEVM. So this is intent e-valid is the encrypted result of our computation. Once we have all this, we can populate the payload for the Zama coprocessor. This is a list of ciphertext defined as bytes 32. We can now request decryption for this ciphertext object. And yeah, again, you can follow the documentation for the way in which this is done. But this is then the function that's pinged back by Zama. And here, basically, I am doing this. Actually, I'm doing this. We didn't want to make the graph too complex, but the user story I'm showing now is basically from portfolio manager to fund, from fund to FHE coprocessor and back. And I have my decrypted state. Once I have my decrypted state, I can redecode it, and I have my Boolean here. So today's demo, I wanted to focus on this point. I guess we can go straight into Etherscan and show you how basically, of course, I want to show you the user experience of the Vault Curator because that's the entity for which privacy is paramount. And for this, we have built an SDK. This is done in Python because it's compatible with the quant stack of many of our collaborators and partners. It's again open source. You can find it on pip, just pip install it. And what we did here, I would say, maybe we can mention the work we did on Zama here as well, is to integrate their own SDK. So basically, it's an SDK wrapping the Zama SDK in TypeScript. Before going there, though, we will talk about it when actually calling the submit intent function. Let us define a new vault. So, of course, we are on testnet. But yeah, I just prepared this command, hello Zama Vault Curators. This is all of us. In Orion, we have this SDK. And these are the various commands you can use today. And we can deploy Vault. That's one of the functions we can use. Let's take a look at the helper when it comes to the specific deployer. And let me know if it's too small. So we have a vault type. A vault type is either encrypted or transparent, as I said. We can give a name to the vault, a symbol for the token associated with the vault, a fee type. This is all information related to the UX and the business model of the manager, not the LP and the user of the DApp. But it's crucial also for when it comes to then LP's performance. Fee type, it's absolute. We have a hardware rate. Okay, we don't need to go into detail here. Performance management fee. So we set all these, and we can submit this order directly on chain. Okay, very good. We have our transaction, we have our Sepolia link. We can go and take a look at the indexing. In the meantime, here I opened the address of the core contract of Orion Finance. It's the configuration contract. Here we have many states which are global across all other contracts. For example, I guess we can start using the config once this is done by looking for the newly created vault we just have in the protocol. Okay. So we call this transaction on the Orion encrypted vault factory that you can find here. And this enabled us to create a new Orion vault. Let's take a look again at the vault that was created. Okay, here is the address of the vault. Here we go, Orion encrypted vault. This is the contract I was just showing you. And we can also find it from the configuration contract in the all Orion vaults. This is the list of transparent vaults. In this deployment, there is nothing. This is the list of encrypted vaults. Here are the three of them, and this is the one we just created. Let's look that the address is matching. Yes, it does. Okay, so now we are here. We have a few states associated with the vault, and as we said, what did we say? The symbol, for example, we can take a look at it. Okay, hello Zama Vault Curators, I think it was, yeah. Name, yes. This is what we just did. Now, get intent. Here, there is nothing yet, because no portfolio manager yet interacted with this vault. However, we do have a curator that we can find here. And this is an address I'm using to test the deployments. Fee model, we have it here. We have the fee type is 0 because it's represented as an integer mapping to our absolute fee type. Performance fee in basis points, management fee in basis point, the watermark that's used for fee accounting. Okay. I guess we can go straight into the interaction with the intent submission, and then we can have a discussion on the code itself. So beside the deployment, As we said, the encrypted vault is particularly relevant for asset managers that have off-chain IP. So we expect them to somehow, in a way that we don't specify, generate a portfolio. So in this case, this is the portfolio. It's a JSON that we see here. So as I was saying, it's a tuple of address and percentage DVL. This is a list of percentages summing up to 1. Let's try now this with a valid intent, and now we will see the decryption working for a non-valid intent. So now that we have this, we can use the README to submit an intent. And this is all that's happening from the perspective of the asset manager. As you see here, there is nothing about FHE. They just deployed a vault and they specified this instead of transparent. But that's all they did to make use of this feature. Now they can just submit an intent. Oh, sorry, I called the wrong function. Okay, update the curator. I hope it's the right one. Okay, yeah. So I updated the curator with the one I already had. I guess we also had a transaction. Let's take a look. This is the config contract. This is the vault contract. Yeah, okay. Sorry, I didn't do something very important. After the deployment of the vault, I should have updated the environmental variables to point to the right contract. Sorry about that. So I just submitted an intent to the wrong vault. Let me stop sharing, as I need to. And in the meantime, if there is some question.
Yeah, we have a few questions from the audience. Those are more technical, but might be the good time to have them. So yeah. First question is from Mashiro Rem. So while Zama FHEVM provide the baseline confidentiality for users holding, a true portfolio manager requires running active and conditional logic. How does Orion Finance architecture plan to use FHE to execute complex user-defined rules entirely on encrypted data?
Right. So I would say the specificity of the requirements of portfolio management enable us to focus just on the preserving of the state of the portfolio. There is no need for a portfolio manager to make use of FHEVM today in the construction of the strategy itself. It's just about protecting the outcome, because that's where today's limit is. About the today vault curation business model, today no one is using on-chain logic to generate the rebalancing orders. On-chain states are used as an input.
Okay. Yeah, okay, I see. So yeah, so so I think you answer saying that because your target audience are curators and not real portfolio manager in the traditional finance sense, right?
I mean, yeah, I mean, they need to be managers of basket products, of a basket position of products, and curators are part of this because positions are markets in a lending sense. Managers of those exposures.
Okay. So, okay. Furthermore, so she has another question. How does it handle programmable privacy, for instance, allowing a user to prove to a third-party lending protocol that their vault's value exceeds a 10,000 collateral threshold without ever revealing the vault's actual total value or its composition?
Right. So in today's contracts, this is not yet supported, but it's easily generalizable to or at least, yeah, adaptable to the case of lending. Yeah, I mean, it's a different use case, I would say. The one we are discussing now is showing the overall logic. So we're showing the submission from off-chain of a state which is non-encrypted. It's passing through the Zama coprocessor, the Zama relayer for encryption, goes on chain. It's then requiring a decryption off chain, and then there is a callback. So in a lending example, you would have a transaction in which you use an encrypted loan-to-value state, which is encrypted, and then you request a decryption to Zama, and then you have the outcome. This is kind of similar to what's happening in the Orion infrastructure, in which the internal state orchestrator is taking as an input the callback output from Zama to understand if a vault has a valid intent. So you could think that the internal state orchestrator is to an Orion encrypted vault as a lending market is to a curator lending strategy.
All right, thank you. That's it for the questions. You can go on the code.
Cool. Cool. Okay, so I updated the environmental variable associated with the vault. So now we can submit an intent. What's happening here? Yeah. Apologies about that. We just deployed a new feature in the contracts related to the whitelisting of vault owners. Let me quickly do that. Okay. We are basically moving slowly from a fully permissioned infrastructure to partially permissioned infrastructure. And I would say this is also talking about the requirements we hear from institutional adoption. This is not just about privacy, it's overall about compliance. And privacy is one big subject here. But whitelisting of investment universe asset, whitelisting of curators, and down the line, even gating. And I see this is something very interesting if you look at Metamorpho v2 when it comes to gate or Uniswap v4, the opportunity to define custom logic around basic interactions. All these movements are talking about the satisfaction of SOR requirements for addressing institutional adoption. And so we are moving in the same direction. Why is this not happy with me? Did I add the right vault? I guess for the interest of time, I can just show you a video. Apologies about that. So here it's the state we're at. We have our own off-chain portfolio that's defined in percentage of TVL. We can submit it to an Orion vault. And when we submit it, we receive a state which lives on chain. And that's associated with an encrypted state. So you see what I'm underlining here is just bytes. No one visiting the state of the vault can make use of this state to infer the IP that was used to generate this state. Down the line, however, we have these transactions. As soon as we submitted this intent and we satisfied this transaction, we requested a decryption to the Zama callback function. And so just 20 seconds later, we are able to receive back a transaction happening from Zama to the same contract that was allowed. And on this, maybe I can show you back the allow function from Zama. So we allowed the coprocessor to perform, to treat some variables. So allowing the coprocessor to call back into this function. We are now able to let the coprocessor from Zama without us needing to do anything else as users of the DApp, either curators or LPs. We can wait for just a few seconds for the coprocessor which is the thing we all see here, for it to ping back our contracts and update the state in the vault. So in this case, I can show you is intent valid moves to the default false to true, because this intent was submitted in an Orion intent compatible sense. I think this is the majority of what I wanted to show you. If there are any more questions.
Of course, there are. Thank you, Matteo, for this presentation. It was a bit technical, but for anyone following closely the field of curators, lending in general on DeFi, I think it's a really new primitive that you're showing that are really exciting. So I have questions from Marco. I'm not sure to understand well, but if you do, you'll be able to answer. So Marco is saying, so today it's just real money strat, for example, 100% stablecoin transfer to trade, that notional, or can I go long or short with leverage? I don't know if the question makes sense. If it does, you can answer.
Yeah, it does. I would say, yeah, the assumption is that the portfolio manager of the Orion Vault is long only and unleveraged on an array of assets. Now, this instrument, we are expecting the leverage to happen inside the instrument itself. So you can have looping strategies that are included in the investment universe of the Orion Vault. But then once you have all this, the Orion Vault itself is long only, leverage one. That's correct.
Thank you. The next question is from Abdul Rahman, and I think it's for me. The question is the FHE computation handled entirely on-chain, or do you rely on off-chain component for efficiency? So the answer is it's done off-chain. The real FHE computation, the heavy lifting of our protocol, is done through a piece of architecture we call the coprocessor. So you can check on our documentation. It's explained properly, but Ethereum or any blockchain today do not handle natively FHE. Our story. So at the beginning, when we started working on integrating FHE to blockchain, the first version actually of our blockchain product. We added our library, FHE library, TFHERS, directly as a precompile into the virtual machine. But for lots of reasons, we then decided to move to existing layer one, because as I said earlier, we want to tap into the deep liquidity where the money is, where DeFi happens. And so we couldn't, of course, modify EVM precompiles on Ethereum mainnet. So that's why we choose this architecture, which we believe is the best trade-off that we make. And everything is auditable. So it's not because the coprocessor is centralized that it's bad, because you can check the input, you can check the output, and our library is fully open source. So we are putting at stake, or I would say, our brand equity on this. And so this is something really valuable to us.
Maybe if I can add something on this, because I think it's very interesting, the back and forth that's happening in the background without the portfolio manager knowing. In the case of the encrypted intent submission, basically you can take a look at our CLI, and the encrypt function is basically calling a subprocess. So here we are in Python, we are calling a subprocess using Node and running our SDK, the JavaScript SDK. This is living again in the same repository. And in the bundle, that it's not human readable, but it's coming out of this, we are just basically preparing the payload and submitting it to the relayer from Zama. This relayer is again off-chain, and this is what's enabling us to encrypt a certain portfolio and then submit it to an Orion Vault. So basically, going back to this diagram, there is some back and forth happening as well from the portfolio manager, going into the Python SDK, going to Zama, coming back, then going to the fund, and then once the intent is here, we have the callback actually happening from the on-chain state to the coprocessor. So that's a bit all the back and forth that's hidden from the user experience. That's just about submitting a portfolio.
if you want to go into these details, everything is available in our amazing documentation. So another question, I think this one is also for me. So do you plan to integrate with existing DeFi platform like Aave or Lido to enable FHE-based portfolio management? Oh no, so I think it's for you. So will Orion be natively integrated into Aave, Lido?
Of course, we are now starting integrating, let's say, from the top-down, in a top-down approach. We will start integrating the existing vaults that are part of Aave, Morpho, Lido, Euler. The vision is therefore then to integrate more and more deeply and to bring the vision of confidential curation, let's say, at a lower level. Definitely.
All right, thank you. We don't have any other questions. So I think it's okay on my side. Thank you a lot, Matteo. If you're interested in Orion, do not hesitate to follow him on social media. Follow Orion and Matteo directly on X or LinkedIn.
Yeah. X, LinkedIn, we have a Discord, we have a Telegram, so you can find everything on our website and documentation, orionfinance.ai.
So please also register for the next Zama Builders Ecosystem Builder demo. We have a lot of really interesting projects to come. Last one was Cypher. This week it's Orion, and we have some amazing new ones to come. So thank you all. It's been a pleasure, and see you very soon. If you want to send this video to those people who couldn't attend, everything will be available on YouTube, of course. Thank you. Bye-bye, and see you in a few weeks. Bye.
Bye. Thank you.